This is a very interesting functional equation problem. This was shared and discussed by Tahiri Maths channel. I gave the link in the description. Please go and watch. In this video, I'm going to discuss my approach to this problem. Coming to the problem, we are given a function with the domain as well as codomain as real numbers, and we are given this functional relation f of x into f of y plus f of x is equal to f of x plus x into y, and we need to find the function f of x. The first observation I want to make is this, that is, this function is surjective. That means for any real number a, we can always find a real number m such that f of m is equal to a. This is what we mean by surjective. This is easy to see why. Let me copy this relation here. Alright, suppose this is equal to a. This means f of x plus xy is equal to a. This gives y is equal to a minus f of x divided by x. Now if we substitute this y value here in this expression, we get f of x into f of a minus f of x divided by x plus f of x is equal to a. So for any value a, we can form this expression by choosing any non-zero x value. So that means for any real number a, we can find a real number such that a real number m such that given by this expression such that f of m is equal to a. Therefore this function is surjective. This is the first observation I want to make. Let us proceed to the solution. Let me copy this relation here so that we can work out. Now we are going to make some substitutions for y and x so that we can get some other equations that are solvable. Before that, let us say f of u is equal to 0 for some value u. Since this function is surjective, there should exist some value u, such value. So f of u is equal to 0, and we are going to make these substitutions: y to be u, x to be x. So this relation becomes f of x into f of u plus f of x is equal to f of x plus x into u. Now we have to remember that f of u is equal to 0. Let me mark it here. So this is, since f of u is equal to 0, this is f of x is equal to f of x plus u into x. Let me mark this here. Okay, now we are going to find the nested function f of x in two different ways. Alright, so by this relation we have replaced x with f of x. This is simply f of x plus u into f of x, and f of x is f of x plus u into x plus u into f of x. So this is one expression that we get in one way. Now let us do the same problem in some other way. Now consider the same nested function f of x. Since f of x is equal to f of x plus ux, this is f of x plus ux, this is f of x into x into u plus f of x. Suppose f of t is equal to u. This is again possible because of surjective nature of the function. So suppose f of t is equal to u. This is f of x into f of t plus f of x. Remember the original relation we have here. Let me copy this here. So this is our original relation. Alright, so from this, see, we have x here, we have x here, f of y, instead of f of y we have f of t, we have f of x, we have f of x here. So this is f of x plus x into t. This is directly from the given relation. Therefore this is f of x plus t into x. So we have calculated the nested function in two different ways, and therefore they must be equal, this one and this one. Let me copy this function here. So this is here. So these two must be equal, f of x plus t into x. F of x cancels out. So this is u into x plus f of x is equal to t into x. There is a trivial solution that u is equal to t is equal to 0. That is the trivial solution. This is trivial solution. But suppose u is not is equal to 0 and t is not equal to 0. This means, let us assume this is the case, that u and t are not trivial solutions. Then this means x plus f of x is equal to t by u into x. This gives f of x is equal to t by u minus 1 into x. Now there is a possibility that this quantity is 0. Alright, if that is the case, then f of x is equal to 0 for every x value. But that will lead to contradiction, because we have 0 here, we have 0 here, but this may not be 0. So this value can't be 0, and also this value has to be a constant. If it is not a constant, then this function cannot exist. Okay, therefore this value should be a constant. Let that constant be a. So we have f of x is equal to ax. So let us find and we have noted earlier that f of u is equal to 0. Let us consider that f of u is equal to 0. This means a into u is equal to 0, since f of x is equal to ax. Since a is not equal to 0, u is equal to 0. But this is a contradiction, because we have assumed that u is not equal to 0, right? So this is a contradiction. Therefore this assumption is wrong, and u and d must be equal to 0. Therefore u is equal to 0 and t is equal to 0. Now remember, we have this. What is this? Here f of x is equal to f of x plus ux. Alright, since u is equal to 0, this is simply f of x. Therefore f of x is equal to f of x. Since f of x is surjective, this means f of y is equal to y for all real number y. Therefore our function is f of x is equal to x for all x. And we can easily verify that u and t are 0 by substituting f of 0 is equal to 0, that we know, and so this is 0, and again f of t must be also 0, so that we can easily verify. Therefore the solution to this problem is f of x is equal to x for all x, and the key to the problem is to note that this function is surjective. That is it. Thanks for watching.